Good afternoon, everyone. My name is Eduardo Arango. I'm a software engineer at Scilabs, and today I'm going to talk to you about Singularity for enterprise performance computing. So I guess if you guys are here, you are very interested in running big workloads in the cloud or in your on-prem. So I've been talking with users here, and I'm going to do a quick introduction to what Singularity is, because I know that you guys are not very familiar with the project. It's an open source project. And then I'm going to demo how Singularity integrates really easy with any scheduler and precisely with Nomad scheduler. And I'm going to show how we can be a plugin driver for Nomad. So a brief history so you can guys come up to speed with me. Singularity was a project invented in the National Laboratories here in the backyard in Berkeley. To resolve a specific HPC problem. So users start to knock the door for system admins requesting the microservices containers to get installed in multi-tenant environments, and that's a no, right? Like, we need something more secure. So Singularity is born 2 years ago to respond to this need of the researchers and people asking for containers for HPC workloads. So it started in 2015. The first official release was in 2016. In April, the 1.0 release. And 3 weeks ago, roughly a month ago, we released the 3.0 release. The user feedback really took us really fast to the 2.0 release, on which we supported squash effects images. And we took the project really beyond what it was in the 1.0 release. So with the success of the 2.0 release, Greg founded Scilabs in January this year, so we are a pretty new company. We have now 25 employees, and we have a suite of products to help you guys to run HPC workloads, and we are already getting users and revenue. So as I told you guys, back in October 8th, we released the 3.0, doing a code overhaul. So the 2.0 release was a weird mix-up of Python, Bash, and C code. Now it's only Go and C. So it's really easy to go and read the code and jump in and start contributing and start integrating Singularity with your projects, because Go is the cloud language, right? Like, it's what I'm going to show today, how it really integrates with a different Go project as Nomad. Singularity, what makes Singularity different? So people always ask, well, you're another container in the container ecosystem, right? Like, what is different for Singularity? So it was designed for HPC workloads. We are not thinking in the microservices world of having these really small containers and caring about how can I make my container even smaller every day. No, we care about users that have 20 gigs containers, 30 gigs container. Last week, I was in a meeting with a user with a 40 gigs container as a base. So this is one thing that differentiates us, is really focus on security. So as I told you, what really makes Singularity born was the security context, because the other containers in the ecosystem are not secure for a multi-tenant environment. So Singularity is super focused on security, and our first priority is always making a runtime ultra secure for the system admin. The Singularity image format. So we are proposing a really container-based image format. So we are not using tar files. We're not using what the other container runtimes are doing. We develop our own image format that users can actually cryptographically sign and verify, and makes it really easy to track the data and track the binaries and track like AI and ML engines that you are going to train and build and then store in that image file. You can store metadata also in that image file. I'm going to show you in the next slide how it works. And we are always thinking in integration over isolation. So the other container runtimes are always thinking in how can I isolate more from the host. We are always thinking even by using namespaces and C groups, how can we integrate more with the host and give the user access to all the drivers? Because in HPC, people want to use Infiniband, people want to use GPUs, people want to use one container to leverage the whole host, the whole cluster, not just how can I run 10,000 of containers on the same host. We are interested in how one container can eat the whole host for a single process. So as I was telling you, we have MPI integration, so you can run Singularity from MPI, not installing MPI inside the container, inside the image, but you can run MPI jobs within MPI. So you can do MPI run Singularity image, and it is going to jump into the process pool as an MPI job and not a Singularity job. So we integrate really easy with MPI jobs. We are transparent for GPU support, so just running a Singularity --MB for NVIDIA, and you're going to get all the GPUs available in the host, and you don't have to install drivers, and you don't have to do anything inside the container image. And we also integrate really easy with NVIDIA Container Cloud. So if you want to use a GPU-based workload, Singularity is the container to be. And we have integration batch schedulers. What's new in 3.0 that is really interesting for the cloud people is we now have a rewrite in C and Go, but all the plugins on which you can start integrating with us are in Go. The C portion is just the engine, the core runtime. You don't need to touch that code. You just need to integrate with the Go code. The Sieve is now a default container format. So in the 2.x version, it was something very experimental. Now in 3.0, we are releasing Sieve. Also, Sieve is an open source project, so you can go into the Scilab's GitHub account and look for the Sieve repo and start contributing there also. And we have some cloud infrastructure to help the users. Cloud infrastructure like our self-container library, a remote builder, and a key storage that fully integrates with the 3.0 release. So why a remote builder? So in this multi-tenant environment on many companies, users don't have root access even in their laptops, right? So we need to give users the possibility to build their images before running their images. So we have a cloud-based infrastructure on which the user tells us how they want to build an image. We build the image for the user and give it back to the user and store the metadata in the base container that we use for that build in our container library. So the users can always come back and see that remote build that they did, and they can download it again. The ability to run from local Docker and OCI images, so we really easy integrate with the layer file system that Docker and OCI propose. We translate that into the Sieve format, so you don't need to worry about how do I translate from Docker, from OCI, from the XYZ container runtime that you are using right now. You can just import that container runtime, that container image into the Sieve format and start running that with Singularity. 3.0 now support network virtualization and C groups. For that, you need to be root. So Singularity, since 3 years ago, has been a rootless containers from the background. But now people start requesting network and C group support. This kind of system calls request some kind of permissions. So for running these two new features, you need to be root in order to run these new features. And also, again, we are a secure-based company, so 3.0 has some really cool new security features that if you want to try it. So this is a quick 101 of Singularity images. This is how you define a Singularity image. It's kind of different of how you're used to see a Docker file. This is our Singularity file, where you define how you want a container to be. So you can pull even images from a operating system repository, right? Like you can say, bring me the OS directly from Ubuntu, bring me the OS directly from CentOS, from Red Hat, from SUSE. And then you can define the steps on which the container is going to behave and what the container is going to have. And you can also, here in the Bootstrap section, define Docker and build a Singularity image from an image in the Docker Hub or in the local registry of Docker in your host. So this is our big release this year, the zip format. And here you can see the really cool things that we are proposing different from the layer system. So we are proposing a single file container that can also then behave as a compiled binary in the host. So in this, you can also cryptographically sign that because it's just one file, right? In that file, you're going to have your OS or your metadata or your dependencies, your environment, and you can bring that image format anywhere in a USB. Why? Because it's not a layer system that you need to export, save, import. No. We are telling you where is that file, and you can move that file as any file in Linux, right? And this is what is inside that zip format. So if you're more interested in what is zip, I invite you to go to Scilab's repo and start looking at it. This is all made in Go code. So here is the beginning of this talk. So how Singularity really is helping and is giving users the power to run enterprise performance computing, not microservices, not 10,000 containers in a single host. This is how users are leveraging their workflows with Singularity. So we are now using MPI for Omnipath, for Infiniband, for deep learning, data science, AI, machine learning. So with a single image file, you can run a process in a whole cluster with just one image. So that's the really big difference of Singularity. And why I'm here in HashiCorp is how you can use Nomad to call Singularity and run a big workload. So Singularity is compatible with any resource manager. I was talking yesterday, and I think I start to speak like in Chinese because no one understands me. So Singularity really integrates with batch schedulers like htCondor, Slurm, Univa Grid Engine, PVS, Torque. Why? Because after you build the image and you have that zip file, you can actually run it as a binary, / your file, and it is going to run as a process in the host, and it is a contained process. So you don't need to do anything special to integrate with a resource manager. But why are we here? For Nomad. Also, we don't have a container daemon. So that's something really insecure that we want to avoid. So you can just run from a shell, from a bash script, call the Singularity image format, or call Singularity to code the image format, and run your workflow. So we are also proposing a ecosystem for container services that are needed to be suited for big workloads and non-microservices. So with the 3.0 release, we are presenting users a container services platform for EVIT cloud solutions. We are giving users a way to do a CI/CD workflows by using the remote builder and the container library to define a workflow and then run in their host in a very secure way. So these are our 3 cloud services right now. You can store in Singularity, in Scilab's cloud, your key on which you sign your zip images is PGP keys. And then you can download, you can pull that key in a different host and verify that image, right? As I told you, we have a build service to help users to build images in a container library. So we are a full open source company. Everything that we do is open source. So you can just go to Scilab's repo and start looking everything that we do. We are working everything in Go right now. At Scilab, we are supporting a Singularity Pro solution that is like Red Hat versus Fedora, right? That's the difference between open source and our commercial services. And we are always secure. So our roadmap, if you're interested in jumping and helping us in the open source version, the 3.0 is going to also introduce the plugin framework. Now I'm talking about plugins today. And future Singularity version are going to introduce native Kubernetes integration. So the biggest wall that we are hearing right now is how to integrate our image format with Kubernetes, because Kubernetes is expecting the layered file system. But for the 3.0 release, we are hoping we are getting that solved. And we are hiring. So now I'm going to jump to the demo. Let me see if we can, here, okay. Here. Okay, so yesterday, thanks to Michael, we wrote a Singularity plugin driver that they presented today in the 11 a.m. talk. So you're going to see a running Nomad plugin that gives native Singularity support for Nomad services. Oh, it does, because it's Beast code. Is that better? Well, that's Nomad logs right now. Well, this is not important. What is important, I can do it in the other terminal. Here. Wow, it's super small. Yeah, I can also don't see it here, so let me check. Why is it not going bigger if I do? Oh, yeah. Sometimes it just doesn't work. So here you can see that we are running a Nomad service with a Singularity healthy driver. And now, for the fun part, so let me, but it's super small. Let me see if here is better. Yeah, here is better. So this is a super quick Nomad job. I'm going to use the Nomad artifact to download an image. It's a photo for San Francisco. And I'm going to run a pre-trained machine learning algorithm for image detection and run over that image with Nomad and get the output. And hopefully it still works as it was working before the 11 a.m. talk. So now, here it is. So this is the image that we are downloading with the Nomad artifacts, and this is the image processed with Singularity using AI and Nomad in a single raw flow. So you just saw how can you really easy use Nomad with Singularity for AI and machine learning workflows. So you can download your input data and tell Singularity with your pre-trained engine to run things. And thank you.